All right, guys, so we're going to talk about chemical reactions, law of conservation of mass, and some basics on chemical equations. Now, I'm going to put up here an equation that we all kind of know from life science, which is 6CO2 plus 6H2O. If that makes it a little bit better. All that goes to make C6H12 12O6 plus 6O2. Now, we see here, we know this equation from photosynthesis, right? So we have 6 carbons on this side of the equation and 6 and 12 oxygens, okay? We have 6 times 2 is... All right, so we know this equation from life science. Here we have a balanced equation for photosynthesis. The reason I'm using this equation is just to kind of get us started and kind of get us a general idea of equations that we've seen before. So what this is telling us is we have 6 CO2 molecules, we have 6 H2O molecules. All that goes to make 1 glucose molecule right here, and 6 oxygen, okay? So we've seen this equation. I kind of want to introduce it and just kind of show it to you because we've seen it before. Now, a chemical reaction, all a chemical reaction is just a change when one or more substance is converted to something else, okay? Now, this is important to remember because we talked about physical changes and chemical changes. Physical changes is when two things mix together, they don't chemically bond, but here we have something becoming something new. So it becomes something different, can't undo it necessarily, so we end up with a chemical reaction. Now, everything on the left side of your equation is your reactants. Everything on the right side of your equation is your products. So, law of conservation of mass and matter, okay? In a chemical reaction, nothing is created nor destroyed, okay? They're just rearranged a little bit, okay? So you can see here we have 2 sets of hydrogen gas, H2. We have 1 set of O2. That all goes to make, we end up with 2 waters. Okay, so we see that we had 4 over here, and 4 hydrogens, we end up with 4 hydrogens. We have 2 oxygens, we end up with 2 oxygens. So nothing is really lost nor destroyed, or we don't come up with anything new. All right, we just end up with transferring, kind of rearranging these 2 guys into this. All right, so this is one sentence, kind of tells us everything we need to know. Nothing really to write here. Aqueous lead nitrate plus 2 units of aqueous potassium iodine produces solid lead to iodine and 2 units of potassium nitrate. So all that's saying is we have this. It's aqueous. We'll talk more about that in a minute. We have this, 2 units, like it says. And we form this. So we can see how in this reaction we started with 2 things, we end with 2 things that are different. That's kind of the point of this slide. All right, and we'll talk a little bit more about coefficients in a minute. But the coefficient is what goes on the front to tell us how many of this compound we have. So, coefficients. If we're talking about just magnesium by itself, we can refer to it as an atom. So this has 2 atoms of magnesium. So for covalent compounds, we just call them molecules, okay? So CO2, nonmetal, nonmetal. We know a nonmetal is a covalent compound. So the 3 in front of this means we have 3 molecules of carbon dioxide. And then last but not least, if we have an ionic substance, metal, nonmetal, okay, we just use the word units. So we say 4 units of magnesium oxide, okay? Now, go and write these symbols down. We will use them in class. You need all of them, okay? So the arrow means produce or to form, okay? The plus means plus and combines with or adds to or anything like that. These are pretty basic. S means solid, L means liquid, G means gas, AQ means aqueous, which is just means dissolved in water. So if we go back, we can see that this is aqueous, this is aqueous, meaning dissolved in water again. This one is solid, but this one is aqueous as well, okay?